Hello students. In my previous videos, we have already learned how we can solve the set of linear equation using the direct method. Direct methods poses some problems when the system grows larger or when most of the coefficients are 0. In such cases, iterative methods provide an alternate. For example, ill-conditioned systems can be solved by iterative methods without facing the problem of round of errors. So Gauss-Seidel method is one of an iterative method which we can use to solve the set of linear equations. So today I have taken an example of Gauss-Seidel method which we will try to solve in this video. So my problem here is 10x1 plus x2 plus 2x3 is equal to 44. 2x1 plus 10x2 plus x3 is equal to 51. x1 plus 2x2 plus 10x3 is equal to 61. Now we will solve this set of equations using the Gauss-Seidel method. The first step in the Gauss-Seidel method is to solve the equation for diagonal elements. Diagonal element means the x1 element in the first equation, x2 element in the second equation, and the x3 element in the third equation. So the first step will be our first we will solve the equations for diagonal elements. When we will solve it for the diagonal elements, therefore our x1 in the first equation will be equal to 44 minus x2, because we will shift this x2 to this side, it will be minus x2. Similarly, we will shift this term to this side, it will be minus 2x3 whole divided by 10. Because the coefficient of x1 here is 10, it is in multiply here. When it will shift its side, it will be in the division, so it will be divided by 10. So this is our x1. Similarly, our x2, when we will solve it for the second equation, will be equal to 51 minus 2x1 minus x3 divided by 10. We will solve x3 for the third equation. It will be 61 minus x1 minus 2x2 divided by 10. So this is our first step. Now we will start our iterations. In our iteration 1, we will assume the value of x2 and x3 as 0, the initial value of x2 and x3 as 0, and we will get the value of x1. So we will do it, we will start the iterations now. Now iteration 1 will be we will let x2 is equal to x3 is equal to 0. We will let both of these values as 0 and we will get the value of x1. So the x1 value will be equivalent to the first, we have to write the equation first, 44 minus x2 minus 2x3 divided by 10. So we will put the value of x2 and x3 as 0 in this equation. It will be equivalent to 44 minus 0 minus 2 multiplied by 0 divided by 10. So when you calculate it, it will be equivalent to 4.4000. Now we will solve the x2 in the same iteration. Our x2 equation is, which we got as 51 minus 2x1 minus x3 divided by 10. So it will be equal to 51 minus 2x1. The value of x1 is 4.4000 as we got it from the first step in the first iteration. So we will put that value in this equation here, and 2, the value of x3 is 0 because we have assumed is that 0 divided by 10 as in the equation. So when you calculate it, it will be equal to 4.2200. Then we have the x3. Our x3 equation is 61 minus x1 minus 2x2 divided by 10. Now we have the new value of x1 and the new value of x2. We will put these two values in the x3 and we will get the value of x3. So it will be 61 minus the value of x1 is 4.4000 minus 2 multiplied by the value of x2 is 4.2200, this whole divided by 10. So it will be equivalent to 4.8160. Now we will start our iteration second for the same values. We will now start the iteration second. So this question we have to solve actually up to the 4 significant digits. We have to solve it for the 4 significant digits. Now our iteration 2 will be, we will assume in our iteration 2 x2 value as the new x2 value 4.2200, which we got in the first iteration, and the x3 value as 4.8160, which we got in this iteration. Now we will again put the values of x2 and x3, the new values of x2 and x3 in the equation, this equation. That will be 44 minus 4.2200 minus 2 multiplied by the value of x3, the new value of x3 is 4.8160 whole divided by 10. So that will be equivalent to 3.0148. So when you calculate the x2 value, the x2 will be equivalent to 51, as our equation is x2 is equal to 51 minus 2 multiplied by the new value of x1, that is 3.0148 minus 4.8160 divided by 10. That will be equivalent to, if you will calculate it, it will be equivalent to 4.0154. As we have to take up to the 4 significant digits, that's why we are writing the values up to the 4 significant digits here. Similarly, the x3 value will be equivalent to, in the second iteration, the x3 value will be equivalent to 61 minus, we have the x3 equation as 61 minus x1 minus 2x2 whole divided by 10. So that will be equivalent to 61 minus 3.0148 minus 2 multiplied by 4.0154, which we just got, divided by 10. So that will be equivalent to 4.9954. Now we will start with the iteration third. We will stop when we will see there is no significant change or there is no change in the 4 significant digits in the previous and the next iteration. So at that time we will stop our iterations. So in our iteration third, our x2 is equal to 4.0154, which we got in the previous iteration, and x3 is equal to 4.9954. Now again we will put it in the same equation which we have got in the first step. So our x1 will be equal to 44 minus, that is equal to x2 2x3 divided by 10. If you will calculate it, it is equivalent to 44 minus 4.0154 minus 2 multiplied by 4.9954 whole divided by 10. So when you will calculate it, it will be equivalent to 2.9994. So now you have to calculate the value of x2. The equation of x2 is 551 minus 2 into x1 minus x3 whole divided by 10. So you have to put the values in it. It will be equivalent to 51 minus 2 multiplied by 2.9994, which we got just now in this iteration. So we are putting the new values of x1, x2 and x3, and the value of x3 to 4.9954, and it will be whole multiplied by 10. If you will calculate it, it will come as 4.0006. So our x2 value is 4.0006. Now we have to calculate it for the x3. When we will calculate it for the x3, the values will come as 61 minus x1 minus 2x2 whole divided by 10. So when you will put the new values in it, you will get the answer as 4.9999. You just put the values in it, you will get the answer as 4.9999. Now we have the values here as 4.9999 in the x3. In the previous iteration, our x3 value was 4.9954, but we have to check it up to the 4 significant digits. So we have to do another iteration. So we will move to the next iteration, that will be iteration 4. So in our iteration 4, our x2 is the new value of the x2 which we have calculated in the third iteration, that is 4.0006, and our x3 is equal to 4.9999, which we calculated in the previous iteration. Now we will put the values in the first equation, that is x1 is equal to will be equivalent to 44 minus x2 minus 2x3 divided by 10. If you will calculate it, it will be equal to 44 minus 4.0006 minus 2. The value of x3 is 4.9999. So its whole divided by 10. When you will calculate it, it will come as 3.0000. Now if you similarly calculate the value of x2, it will come as 51 minus 2 multiplied by 3.0000, because the new value of the x1 is 3.000. That's why we are taking it as here. So minus 4 as in the equation, minus 4 point, that's x3, the value of new x3, 9999 whole divided by 10. If you will calculate it, it will come as 4.0000. Now the value of x3 will be equal to 61 minus x1 minus 2x2 divided by 10. So we will put the new values of x1, that is 3.0000 minus 2 multiplied by new value of x2, that is 4.0000 whole divided by 10. If you will calculate it, it will come as 5.0000. Now if you will see, there is a change in iteration 3rd and 4th in the values of x1, x2 and x3. That means we have to again move on to the next iteration. We will do it for the iteration 5. In iteration 5, we will take the value of x2 as the new value of x2 which we have calculated in the previous iteration, that is 4.0000, and the new value of the x3 which we have calculated in the previous iteration, that is 5.0000. Now we will calculate the x1 value. If you will calculate the x1 value in the similar way, it will come as 44 minus 4.0000 minus 2 multiplied by 5.0000 whole divided by 10. If you will calculate it, it will come as 3.0000. Similarly, we will calculate the value of x2. It will be equal to 51 minus 2 multiplied by 3.0000 minus 5.0000 whole divided by 10. If you will calculate it, it will come as 4.0000. Similarly, we will calculate the values of x3. If you will calculate the values of x3 in the same way, in this equation you have to put, it will be 61 minus x1 minus 2 for this value 4.0000 whole divided by 10. if you will calculate it, it will come as 5.0000. Now if you will see that the value of x1 in the fourth iteration is 3.000 and in the fifth iteration it is 3.000. Similarly, the value of x2 has not changed in the fourth iteration to the fifth iteration. The values are same up to the 4 significant digits, and similarly in x3 we are getting the value as 5.0000 in the 4 iteration, and in the fifth iteration we are getting the value of x3 as 5.0000 in the fifth iteration. That means there is no change from fourth iteration to the fifth iteration in the value of x3, x2 and x1. When there is no change up to the 4 significant digits, because in our question it was given that up to the 4 significant digit we have to check the accuracy. So up to the 4 significant digit you can see that there is no change in the fourth iteration and the fifth iteration. Therefore we will stop here and we will say the value of x1 is equal to 3, the value of x2 is equal to 4 and the value of x3 is equal to 5. So this is how we solve the set of linear equations using the Gauss-Seidel method. Gauss-Seidel method is the iterative method which we use to solve the set of linear equations. So thank you.